Hi,
Hi,
sir.
how are you doing?
I'm good. How are you?
Good, good. So, could you get a chance of going through the question paper which I had shared with you, the examination test review online?
Yeah.
How do you find it?
All right. Just a few hurdles that I came across, but yeah, I watched some of the other videos and used those concepts here.
Very good. And how did you find our earlier session on how to go through an examination test paper and how to actually attempt it?
Really helpful. Like when I get and do exams now, I know to quickly do a rough scan of the whole thing, so I get an idea of what the test paper is about. So that's a really useful tip when attempting exam questions.
Yeah, sure. So I hope that helps you. Now
Yeah.
I'll share with you the screen and we'll go through the examination test papers.
Okay.
While we are going through those test questions, I'd like you to give me your inputs as how you really solve them, right?
Okay.
And then I'll share with you my solutions. So most of the solutions will be similar to yours because you are my student after all. So let's see how it goes, okay? So let
Okay.
me share the screen with you now. That is the test paper for you. Can you see the screen?
Yeah.
Perfect. So Amy, here is the exam review for you. And as you have seen in the test paper, we have questions related to limits from graph, piecewise functions limit, how to evaluate limits, how to relate limits of functions. We have examples with absolute functions and their interpretation. We might have to sketch function from the limits. And then the last question is about finding quadratic equation from given set of limits, right? So let me go through these questions one by one. In fact, I would like you to go through them and provide me with your solutions since you got about 45 minutes to solve them. So tell me, what did you do in these 45 minutes, starting with question number one?
So with the first question A, I just looked at the graph at the point -3 and looked at it from the left side and the right side. So when you approach it from the left side, you hit the point 1,
Yeah.
right? And then from the right side, you hit the vertical asymptote.
No.
Is that fair to say?
But
No?
right side of -3, you hit the point one from both the sides, since it is a hole. You don't have to go that far, right? So when you're approaching, when we say right side, very close to, arbitrarily close to, that is the meaning of limit, right? So you don't have to go that far, right? So you're on
Oh,
this path and you hit the same hole and the value is 1, correct? And therefore,
right.
the limit when x approaches -3 is 1.
It's 1.
In part B, as I told you, there's a correction. We are approaching -1 from left side. So I try to put this minus here, right? Uh, not in this one. It is in the next one. Okay, that's fine. Not in this one. Okay. So rest of the questions. Did you had any difficulty? But it's good to know your answer. For part B, what is your answer? Limit for the function when x approaches -1.
Got 3.
It should be does not exist. This is an endpoint. Since it is an endpoint, you cannot approach from the left side. Correct? Can you?
Oh, no.
No. So you can only approach from the right side. It's a very tricky question. Now, whenever you're trying to find a limit at a point, you should be in a position to approach from both the sides, the same value. Only then the limit exists, otherwise not. In this case, you can only approach from the right side. Therefore, the limit does not exist, right?
All right.
Number 1C, what is your answer? Limit of f of x when x approaches 2, minus means from the left side. Yes.
I got 0.
So when you're approaching 2 from the left side, 0 is correct answer. That is right. D. From the right side, it is?
0.
Why is 0? From the right side, you're on this curve. And so you reach this hole, which is approaching 1. So it is actually 1, not 0. Correct? Is that
Okay.
clear? Right? So the limit really does not exist at x when x approaches 2. You get an idea, right?
Wait, so when you approach the number, if
Yeah.
you encounter other lines, then do they get hit first and then you
No,
go on
no,
to them?
just go very close. So you want to approach 2. Just be
Yeah.
close by, right? Don't go that far. Just see this. Go from here, you are approaching left side and this is your right side. Do you understand? Very close. So very close is this point on the right. So you are on this path. You get the idea?
Oh, oh, okay.
So don't hit the other line. No, we are not dealing with this line at all. Is that okay?
Oh, okay.
Very close. Therefore, here also -2, you are approaching from left side and right side. That means you're kind of here only, right? Do you understand?
Right. Yeah.
Go here. Perfect.
Mm-hmm.
Right.
Okay.
So now E and F. Limit approaching x approaching -infinity. What is the limit of the function?
I got 0,
Correct. And plus infinity.
3.
Correct. Now what is the domain of this particular function?
So domain, I got x belongs to real numbers.
Mm-hmm.
And then I got y belongs to real numbers, but y is
No.
less. Oh.
There are discontinuities in between for x. So you have to incorporate all these discontinuities. So let me share with you the solution of this particular question. Now, as you can see here in the solution very clearly, that as far as the domain is concerned, the whole is not in the domain, right? So you have to filter it out. Whole is not in the domain of the function, correct?
Right, yeah.
So only left side of -3 is in the domain, and that is why we get this part. Union means what are the other parts? Well, after this, up to the vertical asymptote is in the domain. So this portion is also in the domain. Now there's a break. In between from -2 to -1, there is a break. Nothing there, right?
Mm-hmm.
3 was your end point, right? This was your end point at -1. But after -1, it is like all numbers. So x greater than equal to -1. Do you see how tricky it is?
Yeah.
Very complicated. It may look extremely simple. So when you see the test paper, you will find the first question like this to be extremely simple, and you'll do a lot of careless mistakes as you did. Do you see
Yeah.
that?
Yeah.
Be careful. Be careful. Now, tell me again, what is the range? Correct your answer and tell me what is the range?
So y needs to be greater than or equal to
Yes, that is correct.
-3.
That is correct. So that is what it is, right? That is how you're going to answer this particular question. Let's move on to question number 3 now. Now, question number 3 is a piecewise function. Perfect.
Mm-hmm.
So as you move along, and now here there was a correction. -1 we were trying to approach from both the sides. This is from negative side, right? And that is from positive side. And then we'll find the limit of the function at -1. Now, when you get this kind of a function, so you got all the limits?
I mean, I had found trouble sketching the graph. Do you think we could do that?
Okay, so let's look into the solution and understand how to sketch the graph easily. So here is the solution where the graph is given to you on the right hand side. Perfect. Now, Amy, I would like you to explain me how will you sketch this graph from the given piecewise function, as that could be another question, right?
Right.
So explain.
So, okay. So what I did with I got the second condition where it says x and then x is between -1 and 1.
Okay.
So because it's the equal to sign, they should be filled in holes at -1 and 1.
Yes.
Then the top one, it's x plus 1 whole squared. So that's a quadratic, but it's less than -1. So you can only draw the quadratic curve going in the left-hand side direction. Yeah.
That is correct.
Like that. And then
Continue.
the last one I didn't really get why. So was it curved because it's minus x squared?
Okay, it's going down because it is minus x squared. You could factor this. Once you factor x out, you get 2 minus x. So that graph actually will have two zeros. One at x equals to 0, the other one will be at x equals to 2. We have drawn x equals to 2 since our domain is x greater than 1, not the other part, right? In between, there is a maximum for this point. So at 1, just substitute 1 here. When I substitute 1, I get 2 times 1 as 1 minus 1. 2 minus 1 is what? 2 minus 1 is 1. And so we got this value. Is that clear to you now?
Right. Okay.
That is the value which we calculated just now. So you know the graph has to go down. The x-intercept is at 2. That is not necessary for this particular question. However, it is important, right? So you know this graph going down from this particular point. Once you have your graph in place, for which you have already calculated all the values given in the piecewise function, that helps you to check your solution, correct?
Yeah.
How do you get these values? While answering, when we say limit x approaches 2, you plug in 2 because 2 lies in the third leg, right? Third piece. 2x minus x squared, x greater than 1. That means we are looking into this particular portion, correct? So you will use this equation 2x minus x squared, substitute 2 for x, calculate your answer. 2 times 2 is 4, and x squared is also 4, 2 squared. 4 minus 4 is 0. So you get this point 0 right there at 2, right?
Can you find that point without subbing it in, or do you have to?
Because it is a continuous function, as you said earlier. It is a continuous function, and therefore you sub it in and get the easy, right?
Okay. Yeah.
So, and you know the function starts at 1, moves on in between all points, limit, and the value of the function is same because it is a continuous function. So when you start describing this particular graph, you could begin by saying that all the 3 legs are continuous within their own limits. Now, whether there are discontinuities or not, it really depends on the 3 points where they overlap. And one is -1, the other one is at 1, rather 2 points, where the 3 pieces of your graph meet. If they meet at a point, as it does at 1, then it's continuous there, and it does not meet at -1, we have a jump discontinuity, correct? So sometimes required, you could answer later. But now, once you have your graph, you could easily answer all the questions. Either way, you could answer the questions and then make your graph side by side and check your solution. Clear?
Yeah.
So now explain me why the limit does not exist at x as x approaches -1.
Because so when you approach x, when you approach -1 from the left side,
Yes.
It equals 0.
Yes.
And when you approach -1 from the right side, it equals -1. And the two values, they're not equal, so therefore the limit does not exist.
And there's a jump discontinuity limit. One side limit is there. One side limit is there, which is different. So therefore, there is a jump discontinuity. So you could explain that part also, correct?
Right. Okay.
Why is the domain all real numbers in this particular case? There's only one hole here, and at that point, it is covered by the function in between, right? So basically, you see there's continuity, right? All values, we have a value. So it is a continuous function all throughout the domain of real numbers. So that is perfectly fine. Now, we come to the main part of limits, and these are the 6 important questions on finding limits. So I've given you a variety which you could expect in any test paper, beginning with question number 4 to 9. In question number 4, you could directly substitute the value and find the answer. In question number 5, you could do with many different strategies. Now, can you explain me what kind of strategies you utilized to solve these 6 questions?
So, question 4,
yeah.
I did substitution and I got 10. Question 5, I did change of variable.
Okay.
Then I then so I got 125 minus u cubed over u minus 5. Then I just factored it all out, and I got u minus 5 as common. I
Yes.
cancelled them, and my final value was minus 75.
Okay, great. That's correct answer.
Then question 6, is it? Yeah.
Yeah,
So we learned previously tan x equals sine x over cos x.
correct.
Then I found a common denominator as cos x.
Perfect.
Then I took out sine x and did 1 minus cos x
Yes.
over cos x. And I cancelled the sine x. On the denominator, you get sine square x.
Yes.
Then I did, so it's 1 minus cos x over cos x bracket 1 minus cos square x.
Yes.
And then when you can, then the 1 minus cos square x, you can expand it into, so the denominator would be cos x bracket 1 minus cos x over 1 plus cos x. Then you can cancel the numerator and the denominator of 1 minus cos x. Then you get 1 over cos x bracket 1 plus cos x.
Yes.
Then you just sub in the 0.
Nailed it.
And you get half.
Great job, Abby. That was
Right.
brilliant. Next question. Question number 7.
Question 7. This was quite tricky, but what did I do? So I started off by taking the x out of the bracket. So I got x bracket 2 minus 3 over x bracket, and then on the denominator I got square root x squared bracket 9 plus 5x squared. So when x approaches minus infinity, that minus 3 over x and 5 over x squared, they almost become 0. So you can just cancel them out. Then you get, so this is the key point, where when you square root of x squared is absolute value of x.
Yes.
So you get the two values being, on the numerator you get x bracket 2 minus 3 over x over absolute value x plus, no, you get x bracket 2 minus 3 over x over minus x. So we got that because the absolute value x, you need to, because we're going minus infinity,
Yes.
it would be minus x.
Very good. That is what I wanted to explain in my solution. You have already taken care of that.
All right. Yeah, that wasn't really good.
Perfect.
Yeah, and then you get minus 2 over 3. Yeah.
Great job done once again. That's brilliant. So remember, square root of x squared is absolute value of x. When x approaches minus infinity, absolute value of x is minus x, right? So that's kind of important because students think that when you write absolute value of x, it is always a positive number, right? They're not wrong, but they always go wrong, right?
Yeah.
And that's why we put this question here. Question number 8. How did you do?
So what I did was, because we got absolute value function there, so I did the piecewise function. I found the left side and the right side, and for the left side I got -1, and the right side I got 3. So they're not equal, so therefore the limit does not exist because there's a jump discontinuity.
See, Amy, how similar our thinking is. You are exactly solving the questions the way I have solved them. Do you see that?
Right, yeah.
I did exactly the same steps, not only here. Even in the previous questions, I like to share with you. So question number 4, when you answered, you substituted x as 8 and you got square root of 100 and the answer was 10, which is square root of 100. Perfectly fine. Question number 5, 125 minus x here, you did the substitution. U equals to cube root of x and u cube is x, and then it was difference of cubes, you got the answer as minus 75. Now when you went to question number 6, trigonometric function, right? Tan x as ratio of sine and cosine, take common denominator. Now at this stage, I mean, what I normally do is I'll put all this as a different, fraction part. Do you see that? So that I'm avoiding the layer of fractions. At times, there could be 3 or 4 layers, which is very confusing. So let's be clear about it. This is like something over something. I'm writing there times 1 over that thing. So 1 over that thing. Now we start canceling as shown here. Factor out 1 minus cos square x as 1 minus cos x times 1 plus cos x. Cancel those terms, substitute the value to get half as your answer. Correct?
That's a better layout.
Yeah, yeah. So,
It's less
and
messy. I
exactly.
had too many layers.
Yeah, you had 3 layers, right? So,
Yeah.
so I will actually prefer you to, lay it like this so that those multi layers are not there. It is always going to help you not only here but many other places. Calculus will be actually working with very complicated functions. You should know how to simplify them as we move along, because at the end it can be too complicated.
Yeah.
Now, so next question: absolute value of x minus 1 should be written as the piecewise function. Then you figure out left and right limit, get your answers. They are not same, so limit does not exist. So you have to write this. Since they are not same, limit does not exist. Now, question number 9. What did you do about this?
And 9. So yeah, this is the one where I had to watch your video on it.
Okay.
But we started off by taking the x out of the bracket,
Yes.
and I got what you got. So square root x bracket 3 minus 1 over x, all over square root x bracket 5 plus 1 over x plus square root x, and this is the part. So we had to take the cube root of 2x plus 1 aside, because the others, they have the same, like to the power of a half.
Yes.
And the cube root is to the third. So we needed to get it so we can get the x squared, like the square root out.
Yes.
So what we had to do was we had to make that cube root 2x plus 1 into 2x plus 1 squared, square root that, not square root, but like to the 6.
Understood.
How do you say that?
Yes.
Yeah, to the 6, so that that is the same as the cube root one. And then as you go down, you take out x cubed, then you bring out the x 3 over 6. 3 over 6 is the same as a half, so you got square root to the 6, 4 over x plus 4 over x squared plus 1 over x cubed.
Yes.
Then you sub that whole thing back into the denominator. Then you can cancel all the square root x's, and you finally, so all the 4 over x squared and everything, because it's approaching infinity, they all become 0. So you finally get square root 3 over square root 5, and that can be written as square root 3 divided by 5.
Perfect. This was actually the most complicated question. And when you see that you have square root x terms here, right? Square root x, square root x. We would like to have square root x there also. X approaches infinity. We have to get rid of this x some way or the other, right? So the best way is to think about writing this as 6 over 3. 6 over 3 can help you, right? Rather, 3 over 6, I should be saying. Sixth root of cube. So 3 over 6 is kind of half, and you get this square root of x. And that is why at this particular stage, you see we have a strategy. We squared the inside term, right?
Yeah.
And then outside we did like half, right?
Yeah.
So 1/3, 1/6, correct? It is exactly the same thing. And that is how you should be doing it. Perfect. So have a good look at this once again. This could be very helpful for all our viewers. Now, question number 10.
It was that part, the
Yeah.
cube root of 2x plus 1.
Yeah.
That part making into the 6th, I found a bit tricky.
It is extremely tricky. I have not seen anybody answering this question correctly so far in the test papers. Okay. So now you've got this strategy, and I hope all those who are watching this particular video will be able to solve such questions, right?
Yeah.
Yeah. This question has been taken from, let me tell you, IIT JEE entrance examinations. So we have Institute of Technology entrance examination in India, which is extremely tough. So this question has come from that particular place. So yeah, it looks like a simple subject of limits. They think what will they ask about, but this could be a simple looking question, extremely difficult to solve.
Yeah.
Yes. Now here is question 10 to 12. Uh, can you answer these questions now? You have understood the concept in our discussion, right?
Yeah. So,
Yes. Please.
question 10.
Yes.
Given that the limit x approaches 0, f of x plus g of x exists, write functions f of x and g of x such that the limit as x approaches 0 of both the functions do not exist. So
Yes.
what you said was make f of x equals 1 over x, because at 1 over x we learn with the reciprocal graphs as x approaches 0 the limits do not exist,
Correct.
and we need to so if we got 1 over x as 1, we need to find what the other one is, so we're adding f of x and g of x.
Yes.
So when you add, so we have to make, let's say, make g of x minus 1 over x, and
Correct.
when you add them you get 0, and 0 is a constant, so a limit exists, so
Yes.
that's the value. Yeah.
Brilliant. That's a good idea, and actually, it's a very difficult thought which could come in any test paper. So you should know about it. Otherwise, this simple question, simple looking question, could be the most difficult question in this test paper.
Mm.
Question number 11.
So with question 11, I took the, like, should I just read what I've written?
Yes, sure.
So I've got limit as x approaches 3, bracket limit as x approaches 3 f of x, bracket again cube root. So because we know that f of x equals 2, I'm trying to take that, like the thing that they've given, and make
Yes.
it as its own little factor. So once
Correct.
I get a nice formula, I can just sub the 2 back in.
Yes.
So then I get limit x approaches 3x squared divided by limit x approaches 3 f of x minus limit x approaches 3 of 5. So then I sub 2, so 2 cubed minus 3 squared over 2 minus 5. 5 is a constant, so it stays the same. Then that's 8 minus 9, which is minus 1. 2
Yes.
minus 5 is minus 3. Minus 1 divided by minus 3 is a third.
You are right. Question number 12.
Question 12. So, all right, I started off by sketching a graph, yeah. So the easy point to start with is f of minus 2 equals 2, because that's a clear point. So I just went to minus 2, went up to 2, and filled in the hole. Then I went, so limit as x approaches minus 2 from the left side, f of x equals 3. So that means it's a hole at minus 2, 3, and we want it to the left side. So you said just any line. That I didn't get. I thought it had to be a certain line. So I just did a horizontal line to the left.
That is also correct. Horizontal line is perfect.
All right. And then limit as x approaches minus 2 from the right side is 1. So I just go to minus 2, 1, put a hole, and do a horizontal line to the right.
Perfect. Both are correct. So there could be many different answers. Horizontal lines are very good because simple equation, you can say y equals to 3, where, you know, the value of x is less than minus 2. And then you can say y equals to 1, where x is greater than minus 2. So you also have the equations. So sometimes we have to write this as a piecewise function. Your horizontal lines is a better solution. Okay.
Yeah, okay.
Next question. Well, here's the solution of the previous one. Okay. This also, yeah. Now the next question is question number 13, right?
Mm-hmm.
Yeah, explain me, how did you do question number 13?
So, so we know, so what we're told in the question is f of x divided by x is 1.
Yes.
Right. So, but as limit as x approaches 0. So if you sub the 0 into the denominator, we're going to get 0, right? But you can't, that means the limit doesn't exist, but it says that it does because it's 1. So we need to, the only way we can get for it to work, we need to make f of x 0, because 0 over 0 is an indeterminate form, which means the limit can exist.
Correct.
So it's 0.
You are right. That's a good explanation also. And part B.
So we just found out that f of x, so that part helps us with the second part.
Yes.
F of x we said is 0, so 0 divided by g of
Anything.
x, yeah, so 0 divided by anything that's not 0 is 0.
Correct.
Yeah.
Question number 13 is done. Correct. So there's a different way of explaining, Amy, when we are saying this limit f of x over x is existing and it is 1 in this particular case. Uh, that really means it is a case of indeterminate, as you said. And that means that f of x has a factor of x. Once we cancel this particular factor of x, whatever remains, that function's limit is 1, correct? So what I did was I wrote f of x as x times h of x, right? Now when I write this, x and x will cancel. When I substitute 0, I say limit of h of 0 is 1, right? So I should have written 1 here. So limit of h of 0 is 1, correct? So that is how you get this answer of 1, correct? But as far as f of x is concerned, it is product of x and h of x. 0 times anything is 0, so we get 0. Oh, that was for product, right? So 0 times, look here, 0 times anything is 0, so the limit is 0. Perfect? It doesn't mean. So that is how we do. And as you said, once we know that the numerator is approaching 0 and denominator is some other value, then the answer is 0. Perfectly fine. So question number 14 now.
So with question 14, so we see an absolute value of x minus 1. So I just did the piecewise function, and I found, so you do minus x minus 1 where x is less than 1, and then you do x minus 1 where x is greater than or equal to 1. So left side, right side.
Okay, now we should not be writing equal to 1 because x minus 1 is in the denominator, so we have a restriction. So it may be a good idea to fill in here that x is not equal to 1, correct? Limit will exist because for limit, we don't have to be there. We could be very close, arbitrarily close. Now, move on.
So you're saying it's best to always write down the restrictions before we start, just so that we don't make up these mistakes.
Yes,
okay.
That's a good idea, yes.
Cool. Let me just write x does not equal to 1. Okay. Then I found the two sides, and you cancel the common x minus 1 factors. So on the left side, I got it as minus 3.
Yes.
And the right side, I got it as 3. So clearly, minus 3 is not equal to 3. So therefore, the limit does not exist. There's a jump discontinuity.
And you can actually sketch if you want to. Well, that is a part of the question. Sketch the graph and explain the discontinuity. So once you sketch, it is absolutely clear that this is the discontinuity, mainly because the limit exists from either side, but they don't match, right? So there is a discontinuity. There are two different values at x value given to us, correct?
Yeah.
The last question here is to find the quadratic equation. How did you do this particular question? Question 15.
So what I did was I just started with the simple, so they've given conditions, and the one that's the easiest for me to see was f of 0 equals 0. So all I did was sub in the 0 into the quadratic equation, and I got 0 equals 0 plus 0 plus c. So we know that c equals 0.
Correct.
Cool. Then we know, because it's a quadratic equation, we know it's a continuous function. So that's pretty much the key to unlock this problem.
Yes.
So you need to, so when we see limit as x approaches minus 1, f of x equals 3, we know that f of minus 1 equals 3, and f of 2 equals 6. So we've got our 3 points. Then you just use those values, sub it in, and I got 3 equals a minus b, and 6 equals 4a plus 2b.
Perfect.
And I just did simultaneous equations, and you get b as, so you get a as 2, b as minus 1, c as 0. Is that what you got?
That is correct.
Oh, okay.
So that is how you'll be doing it. And as you said, polynomials are continuous functions. Therefore, the value of the limit and the value of the function at that particular point is exactly same. And that helps us to identify 3 points on this quadratic equation. And so it's very easy to find the 3 unknowns a, b, and c, solving the 3 equations simultaneously. I think, Emma, you did a perfect job on this. Excellent. That was
Thanks.
brilliant, actually. Yeah, that was brilliant. And you see, in about half an hour, you actually explained what you did. So definitely in 45 minutes, you could actually nail this test paper. And it was not an easy test paper to begin with.
No, it
So,
wasn't.
correct. So, and I like to understand, and if you would like to share with your own experience of attempting this test paper with others who are watching this video, what will you say?
So I would say, like you said in the beginning, always let's first like scan all the questions and see which ones that you think you're going to get stuck on, and just remember them and be like, don't get all scared or anything. Just like brush past and know that, go into the mindset knowing that you're going to encounter questions like this. But so when you do a quick scan of all the questions, you would know what strategies to use, what things that you've got in your head, and which ones you can use for each question. Some will be more obvious than others. Like when we saw some of the questions, if there's nothing else to do, you can always sketch a graph, make it visual to you, so it's so much easier to see. Um, and when you get stuck on a question, don't spend so much time on it. Move on, because like I also did it, and when I got to one of the questions, I was stuck on it, and I think I spent way too long. And by that time, if I was doing in time conditions, my time would have been up. But as I've seen with Mr. Kumar, I could have attempted the later on questions. So when you get stuck, just move on, and you can always come back. So
Perfect.
that's my advice. Yeah.
I think that's a great tip, and many will benefit watching this video,
Yeah,
right?
definitely.
Emmy, thanks a lot for all your contributions and summarizing this whole thing so well. Now we have done our unit number 2, which was on limits, extremely important, and we have a good foundation to understand derivatives. We also know what are gradients and what are limits and how these things come together. So derivatives, which is the next unit, unit number 3 for us, we'll begin with that tomorrow itself. Uh,
Okay.
to give you a heads up, derivative is gradient, nothing else. So remember that part. It's a short form of writing, and we'll have a different notation. We'll just write f dash x, meaning this is the gradient, right?
Okay.
So you have already done quite a bit about it. So it was actually great that in about 3 lectures to begin with, to get past all what you need to know about calculus, we covered in introduction. Then 2 lectures, we were able to do limits and this brilliant test paper in the third lecture. So
Mm.
in 5 or 6 sessions till now, uh, of half an hour each, we could actually cover our first 2 units. That's a great going. But this could not have been done unless you would have watched, I should say, tons of my videos on each topic and practice.
Yeah,
So
obviously.
that's experience, and you did it great. So now get ready for derivatives. I'll post some links for you. Watch them over so
Okay.
that you're ready for tomorrow's class. And we'll again try to do each topic fairly well so that we could have at the end some brilliant test paper, which will have questions from previous test papers and some competitive exams. So in this test paper also, you had questions from competitive exams like GCSE, IIT JE, and many conducted here in Canada. So I
All
think,
right.
yeah, so I think you're good. Okay, so all the
Yeah,
best. I'm looking forward to tomorrow's session on derivatives.
me too. Thank you so much, sir. I really appreciate it.
Thank you. Bye for now.
Bye for now.